Hi guys, welcome to our YouTube channel. I am Venugopal from Team Cloudy ML. So in this video, we'll be exploring the second problem from arrays topic. So we'll be exploring the problem statement first, and we'll be trying to understand the problem and try to think of an approach based on the question. And then once we have got an efficient approach, we'll try to code it in the Python language. So without wasting any further time, let's quickly dive into the video. So let us understand the problem statement first. So what we are given is we need to sort an array of zeros, ones, and twos without using any sorting algorithm. So we'll be given an array as an input which will have only zeros, ones, and twos, and we need to sort this array without using any sorting algorithm. So it is mentioned that we need to so we shouldn't use any sorting algorithm. So what we can think of initially. So let us think of the approach one. Okay. So what can be the approach one that comes to your mind? So after linking into this input and output, what we can say is in the input we have two zeros. So initially they have put two zeros. In the input we have two ones. So they have put two ones. And then we have only one two. So we have put only one two, right? So this is like we are just getting the count of the zeros, count of the ones, and count of the two. And then just based on the count we are just inputting those many zeros, those many ones, and those many twos into the same array itself, right? So what we want is we want to count the number of zeros, ones, and twos, and based on the count we need to impute those many number of zeros, those many number of ones, and those many number of twos into the same array itself. So what we can do is we can create an array of size 3 that will store the count of zeros, ones, and twos. So this array will store the count of 0, 1, and 2. So initially, this array, this count array will have all values as 0 because the count of 0, 1, and 2 will be initialized to 0. Then after iterating, so for each number in the input list L, what we are gonna do is we are gonna increment this count of that number by 1. Okay, so this will be the process for getting the count of 0, 1, and 2. So this number will range between 0 and 2, right? Because it is mentioned that in the array we have only 0, 1, and 2, and we have initialized this count array with 0, 1, and 2 itself. So this number we want to exceed these indices. So this count array will have the count of 0, 1s, and 2s. So this part is done. Like we have got the count of zeros, ones, and 2s. Now the second part is we need to impute those many zeros, those many ones, and those many twos in the same array itself based on the count of 0, 1, and 2, right? So how this can be done? So what we want is we want these indices 0, 1, and 2, and we want this count as well. So what we can do is for a val in range 3. So this will fetch us like val will iterate over 0, 1, and 2. So this will iterate over 0, 1, and 2, right? And now we have this count. Okay, this count value will be storing the count of this particular value. So C of val. So this will fetch us the value, right? So in the count we have this value for this particular val. Okay, once we have got this count, what we can do is while we are having this count, so while the count is not equal to 0, while the count is not equal to 0, what we want to do is let us initialize another variable that is sort of global, like index equal to 0. What we want to do is we want to impute this impute this value for these many times, like count many times, into the list itself. So what we're doing is L of index equal to the value. So what this will do is, and we'll be decrementing this count. So what essentially it is happening is, so we are iterating over 0, 1 and 2, and we are getting the count of 0, 1 and 2. So in the first iteration, we'll get the count of 0. So let us try to dry run it. And here we are like decrementing the count since we have got the count right. So here let's say we have the val as 0. So the count will become 2, right? So count will become 2. Now 2 is not equal to 0. So L of index is nothing but 0, right? So in the first index, it will store this value. Value is nothing but 0. Then we'll be decrementing the count. So while we are having this count, we are we are decrementing it. So then will count will become 1. Then again count will become 0. So when the count becomes 0, this while loop will be stopped. So here another thing we want to do is we want to increment this index itself, because whenever we are imputing, we want to move to the next value. So let us try to dry run it. So we have this uh, array, right? 0 1 0 2 1 0 1 0 2 1. So this is the array, right? And we have this count array as two zeros, two ones, and 1 2, right? So this is the count array that we have. Now for the first iteration, so where for the first iteration, like for the first iteration, we have this val as 0, and we have the initial count as 2, right? Now for this inner loop, so for this inner loop, what we are doing is, while we have this count, like while we have this count, so count is 2, right? So count is 2. So count, when count is 2, L of index will be nothing but 0. The L of 0 will be 0. Now when the count is decremented, it will become 1, and the index will become 1, right? Because we are incrementing the count and we are decrementing this count. So L of 1 will be 0. Now for the next iteration, what will happen is count will become 0 and index will become 2, right? But since the count is 0, here the count is 0, right? Since the count has become 0, this while loop will end here. So we won't be going to the next iteration, and we'll be having this index as 2 itself. Now what we'll be having is, we'll be moving to the next number. So since we are done with val 0, we'll move to the next number, like for the val equal to 1. So when the val is 1, this count will become again 2, and this whole iteration, like while we have the count, this will be repeated for the val 1 also as well. So in the same way, it will be repeated for the val 2 also. So this is the first approach. Like, just to repeat it once again, we'll be counting the number of zeros, we'll be counting the number of ones, and we'll be counting the number of twos. And based on the count of 0, 1 and 2, we'll be imputing those many zeros, those many ones, and those many twos into the same array. So that was the first approach. Now let's talk about the time complexity of this approach. So since we are using another array like count of size 3, so this will take up a space of 3, and this is constant. We can like say it n. So since n is 3, we are taking is 3. Now we are iterating it over 2 times, right? So n plus n, this will be order of 2n. So order of 2n will be the time complexity. Now let us move on to the next approach. So approach 2. So what is the approach 2? So let me write the list once again. 0 1 0 2 1, right? So approach 2. We have this array as 0 1 2 1. Okay. So we have this array. Now what this approach 2 tells us. So approach 2 will be this algorithm, Dutch national flag algorithm, flag algo. Okay. So this is the approach 2. So here we'll be having these 3 pointers: low, mid, and this high. Okay. And high will be initialized to the n minus 1. N is nothing but the length of the list. or the array. Okay, length of the array. So we will be having these 3 pointers. Now what this Dutch national flag algorithm tells us is all the values from 0 to low are assumed to be zeros. Okay, and all the values from high to n are assumed to be twos, and remaining all are ones. Okay, so that is what this algorithm assumes. Now how to implement this? Okay, so how to implement this in real time? Now we have this low, mid and high, right? So till when we will be running this loop? So mid will be like the current pointer for this. So low will be initialized to 0, mid will be initialized to 0, and high will be initialized to n minus 1. Okay, so high will be initialized to n minus 1. Now what we want to do is we want to run a loop while the mid is not exceeding this high. Okay, so while the mid is less than or equal to high, we are running this loop. Okay, and what we are doing is we are putting some if else statements. Okay, so if we are facing some value 0, okay, if we are facing this value as 0, if this array of the mid is 0, if it is 0, what we are gonna do is we are gonna swap the values at low comma mid. Swap the values at low comma mid. Okay, so we'll be swapping that. We'll be incrementing the low pointer by 1. Okay, so this is what we will do if the array of mid is 0. If if the array of mid, so if the element is not 0 but it is 1, so if it is only 1, what we'll be doing is we'll be just moving our mid pointer. Okay, mid will be incremented, mid plus equal to 1. Here also we need to increment the mid. Okay, else, so if these two conditions are not satisfied, that means that the element is 2. So if it is 2, we'll be swapping the elements at mid comma high. Okay, mid comma high, and then we'll be decrementing this high. Since high is initialized to n minus 1, right? So this will be decremented and mid will be incremented. Okay, so let us go through this once again. So we have these 3 pointers. What this Dutch national flag algorithm tells us is it assumes that all the values from the start to the low index are zeros, and all the values from high index to the end index are twos, and remaining all are one. So this is what this algorithm assumes. Okay, so now how to implement this? We'll be initializing these 3 variables: low, mid and high. So low and mid will be initialized to 0, and high will be initialized to the last element. Now we'll be running a loop while the mid is less than or equal to high, and what we'll be doing is if that element, like the value at mid, is equal to 0, if that value is 0, what we'll be doing is we'll be swapping the element uh, at mid and low. So what this is saying, so 0 1 0 1 2, so this is the array, right? So initially the mid will be here. Okay, since this is 0, it will be like if the mid is 0, what it will do is it will swap the value with the low. So since both are at initially both will be at same, the low will be here and mid will be again incremented to this value. So since this is incremented, what we can do is, so let us take this low as L, M as M and high as H. Okay, so initially L will be here, M will be here. Okay, and when M is 0, these two will be swapped and M will be incremented to 1. Okay, and then this M is 1, right? So since M is 1, what will happen is M will be here itself and M will be incremented to the next step. So M will come here. So one mistake guys, when we had L here itself, so L was also incremented, so L will come here and this will be gone. Okay, since after swapping we are incrementing both L and M. Okay, now what we want to do is, since M is here, M is 0, right? Now what we want to do is we want to swap this value, sorry, So we want to swap this m with the l, right? So what we'll do is we'll swap these two values and we'll again move the pointers. Okay. So what will happen is this 0 will come here, 1 will go here. So this will become 0, this will become 1. Okay. And this will become 1. So the swapping is done. Now the low is here and the mid is incremented to here. So since mid is 1 now, it will again go to here. Okay. And since this was like 2 itself, right? So high will be decremented and mid will be incremented since it has crossing this mid and high. So this condition won't be satisfied and will be breaking the loop. So what we are doing is we are just assuming that what are the elements that are present to the left of the L are zeros and what are the elements that are present to the right of the high are twos and remaining all elements are ones. So that's what we are assuming here. So that's what this Dutch national flag algorithm also tells us. So now till now we have seen two approaches, right? So this is the efficient approach because we are running a single loop. So the time complexity will be order of n, and there is only these three variables that we are using, and the order of the time complexity will be constant itself. So this is like the best algorithm that you can use in order to sort the elements with zeros, ones, and twos itself. Now till now we have seen a sort of pseudocode, right? Let us try to implement this in the Jupyter notebook and try to verify with more number of test cases. So let's quickly dive into the implementation part. Now let us look into the coding part for the problem 2 from Mary's topic of DSA course. So till now we have understood what's the problem statement and what are the different approaches that we can use in order to solve this problem, right? So now let us try to implement the same approach like whatever the two approaches that we have discussed in the form of code. So we have this doc strings as well as the comments that are already written in order to help you out with the coding steps. So we'll be using these comments in order to code the approaches. So in the first approach, so as we discussed, we are going to use a data structure that could store the count of 0, 1, 2. So here we'll be using arrays. So array with size of 3 where each index will represent the count of that particular index. Okay, so that will be the data structure that we'll be using for storing the count of 0, 1, and 2. Now what we want to do is once we have got the count, we need to place those many zeros, ones, and 2 into the same array. So let us quickly code this up. So we are gonna create an array that is count array that will have 0, 0, 0. So these are the three elements, right? It will be initialized to this one. Now for each value, for each number in the list, what we are gonna do is we are gonna just increment the count of that num by 1. So that is what we are doing here. We are just increment the count of each and every number. Like number is nothing but 0, 1, and 2, right? So we'll be incrementing the count at 0, count at 1, and count at 2 based on the number of elements that are present in the array itself. And what we are going to do is we are going to apply the logic here, like we will place those many zeros, those many ones, and those many twos in the same array. So how that can be done? So let us create this index. I will tell you why we are using this index variable, and let us create this index variable and store 0 in it. And what we are going to do is for I comma the value in the count array. So what we are doing is we are just using this enumerate function. So let me quickly write that enumerate. We are using this enumerate function. This enumerate function will directly return us the index as well as the value at that particular index. So what this will return is for 0 how many for 0 what is the count, for 1 what is the count, for 2 what is the count. So that will be like the values that are returned by the enumerate function here. And once we have got that value, what we are going to do is we are going to put a count loop where while the count is not equal to 0, what we are going to do is we are going to assign that particular I. So we are going to assign that particular I to this index, and we are going to increment this index for each and every step, and we are going to decrement the count. So that's what we are going to do is that's what we are going to do, right? So for while we have this count, like while we have the count for that particular I, here I is nothing but zeros, ones, and twos, right? So while we have that count, We are just decrementing the count for each iteration, and we're incrementing the index for each iteration, so that we are just gonna put that particular I, like let's say we have for 0 2 let's say in this array for 0 we have 2 count, right? So if the count is 2, it will iterate for 2 times, and 2 zeros will be put at the respective index itself. And at last what we are gonna do is we are gonna just return that list 1. So let us quickly execute this and try to get see whether we are getting the output or not. Since we have got an error, so what's the error here? So this is count, right? So we have done this wrong here. So this is value, and we need to decrement the value. Since value is nothing but the count, so that's why we are doing that. Now if you see, we have got all the values as sorted, right? So we have 0 0 0. So we have 3 zeros. So 3 zeros we have got here, and we have 1 2 3 4 5 5 ones. So 1 2 3 4 5, and we have 4 twos, right? So that's what we have got here. So this is the approach one. Now let us move on to the approach 2. This is like the Dutch national flag algorithm. So what we want to do is we want to initialize 3 pointers. Like we will make use of 3 pointers: low, mid, and high. And this algorithm assumes that all the elements that are left of the low are zeros, and all the elements that are right of the high are twos, and remaining all elements that are between low and mid are ones. So let us quickly code this up. Now here, based on the comments, what they are telling us, we need to initialize certain variables in order to implement this algorithm. So first of all, let us get the length of the list, and then what we are going to do is we are going to initialize three variables, that is low, which will be initialized to 0, mid will be initialized to 0, and high will be initialized to n minus 1. So n minus 1 is nothing but the last index. Now what we want to do is we want to run a loop. Okay, we want to run a loop while the mid is less than or equal to high. So while mid doesn't exceed the value high, what we want to do is if that particular element, like if the element, if the list of mid, list 1 of mid, so this is the element, right? If this particular element is equal to 0, if that is 0, what we have discussed previously, all the elements that are left to 0, not left to 0, no, that are left to low are zeros, right? So we are gonna swap the value at low and then increment the low by 1 and mid by 1. So that's what we are gonna do here. We are gonna swap the values. So this is like a simple swap logic, right? A comma b is equal to b comma a. So that's what we are doing here. We are just swapping this in this way. So yeah, here swapping is done. Now what we want to do is we want to increment this low by 1. So this can be done using this increment operator, and then we will also increment the mid by 1. So mid. Now next one is we want to check elif, like if this mid value, like the element at mid is not equal to 0, but instead it's equal to 1. List 1 of mid is 1. Then what we are gonna do is we are just gonna increment the mid value by 1. That's it. Because that should be in the middle, right? Because 1 should be in the middle. So there is nothing to be done when we encounter a 1 value. Else, so if it is neither 0 neither 1, then it will be definitely 2, right? Because in our array we have only 3 values, that is 0 1 and 2. Only those values will be present. So if it is 2, then what we are going to do is we are going to swap the value at high with the value at mid, right? We are going to swap those values because it is assumed that all the values that are present right of the high pointer, like high index, are eventually 2s. So we are going to just do this swapping operation here, and let me quickly code that up. And once this is done, what we are going to do is we are going to just decrement the count, because high is initialized to the last element and we want to put all the 2s on the right side of the high. So once we have put the elements on the right side of the high, we are just going to decrement the high with -1. Like we are going to just decrement the high by 1, and we are going to increment the mid by 1. At last we will be returning the same list. Okay, so I hope you have understood. Let me just go through it once again. Initially we have initialized all the variables. Once the initialization is done, what we are doing is we are putting a loop or we are running a loop, and that loop will be running until this condition is satisfied, like until mid is not exceeding the high value. And if we encounter our element 0, if we are encountering 0, what we want to do is we want to put that element on the left side of the low, right? So what we'll do is low will be initially pointing to the first number. So we are gonna just swap the elements, like we are gonna put that 0 at that particular low, and we are gonna put whatever the element at low is at the mid, and we are gonna increment the low by 1 and mid by 1. So what this will do is it will always keep track that all the elements that are present left to low will be zeros. Now, when it is 1, like whatever the element we are facing is 1, what it will do is it will just increment the mid by 1, because whenever we are facing 1, there is nothing to be done based on the algorithm. And whenever we are encountering 2, what we are going to do is we are going to swap the elements at high and mid, because it is assumed that all the elements that are present to the right of the high are 2s. So we are going to swap those elements. We are going to decrement high by 1 and increment mid by 1. At last, we are going to return this list. So if we execute this and try to execute on a test case, we can see these are all the swap values that we are getting. So we have 3 zeros, right? 3 zeros are coming, and 5 ones. We are getting 5 ones and 4 twos. So this is how you can implement this Dutch national flag algorithm. So these were the two approaches for the problem 2 from the arrays topic of DSA course. I hope you understood the approaches as well as the code that is required for the each approach. If you enjoyed the content till now, please do like and share this video with others, and please do subscribe our channel.